Welcome to the Explainer. Today, we're diving into something that sounds like a superpower, but it's real. We're talking about the ability to see the world, not with your eyes, but with your ears.
So, to really get what this is all about, I don't want to start with some dry scientific definition. Instead, let's start with a person, an absolutely incredible person. This is Ben Underwood. When he was just 3 years old, he lost both of his eyes to cancer. He was left completely blind. But that didn't stop him, not even close. He learned to navigate the world with this incredible freedom that just seems, well, impossible for someone without sight. We're talking running, playing basketball, skateboarding, riding a bike, you name it. And how did he do all of this? The secret was a simple, sharp clicking sound he made with his tongue. So the real question here isn't just what he could do, but how. How on earth could a sound paint a detailed enough picture of the world to do all that?
Well, the answer is a skill that honestly sounds like it's straight out of a comic book, but it is 100% real. It's all about turning sound into sight.
It's called human echolocation, and the basic idea is pretty simple, right? You make a sound, like a click, and then you just listen. You listen to how that sound bounces off everything around you, and those echoes, they're packed with a ton of information.
You know, it's funny. When you break it down, echolocation is actually a lot like regular vision. Think about it. Your eyes process light waves bouncing off stuff. With echolocation, your ears are just processing sound waves bouncing off stuff. Both are just your brain's way of interpreting reflected energy to build a map of the world. So, by listening to all the tiny differences in those echoes coming back, a trained person can figure out 3 really important things about an object: exactly where it is, how big it is, and even what it's made of. Like, is it hard or soft? And this is where it gets really cool. This is how all those clues come together to paint that mental picture. So, a tall, narrow-sounding echo, that's got to be a pole. A low, kind of sparse echo, probably a bush. A tall, broad echo that sounds really sparse, that's a fence. The world for them literally takes shape from sound. Okay, so understanding the physics of sound waves is one thing, but that's only half the story. The real magic, the part that completely changes the game, that happens inside the brain. So, let me ask you this. When an expert echolocator is seeing with sound, which part of their brain do you think is doing all the work? You probably guessed the auditory cortex, right? The part for hearing. Well, the reality is way, way cooler than that. Let's just look at the proof. These are fMRI scans of brains. Now, on the right, you've got a sighted person listening to echoes. And yeah, you can see some activity in the hearing parts of the brain as you'd expect. But look at the brain on the left. That's a blind echolocation expert. When they hear those exact same echoes, it's their visual cortex that's lighting up like a Christmas tree, the part of the brain used for seeing. Their brain is literally seeing with sound. This incredible rewiring act has a name: neuroplasticity. It's just a fancy word for the brain's amazing ability to change and reorganize itself. They can form new connections based on what we do. It's like it takes a part of the brain that's not being used for its original job, in this case seeing, and just gives it a totally new one. So let's be super clear about what this means. The brain isn't just hearing an echo and interpreting it. No. It's taking that sound information, that auditory data, and it's processing it as if it were visual data. It is actively building a 3D picture of the world in the very part of the brain that was supposed to be for sight.
And Ben Underwood wasn't a one-off case. This isn't some genetic mutation or rare superpower. It's actually powerful proof of a hidden potential that might just exist in all of us.
Take Daniel Kish. He's a pioneer in this field who created a whole technique he calls flash sonar. And when he describes what he sees, he's not talking about some fuzzy black and white outline. He talks about a rich, detailed world. He can tell the difference between a metal fence and a wooden one, just from the way the sound bounces back. Think about that. And he's not alone. These people are genuine pioneers. You have Daniel Kish, who now teaches his method to others all over the world. You've got Thomas Tajo, who figured this out for himself in a remote village in the Himalayas. And Lawrence Scadden, who, as a kid, learned to ride his bike in traffic using nothing but sound. I mean, these are the people who are showing us what's truly possible.
And get this is what makes it so mind-blowing for all of us. Research shows this isn't some ability that's exclusive to people who are blind. With a bit of training, even sighted people can learn to use sound to see and avoid obstacles. It seems to be a fundamental human ability, just lying dormant for most of us.
So, okay, what's the big takeaway from all of this? What does this amazing ability really tell us?
Well, the main thing is that our brains are not these fixed, hardwired machines. Echolocation proves it. The line we usually draw between seeing and hearing, it's way blurrier than we think. It's more like a suggestion than a rule.
What this really shows is that how we perceive reality isn't just about our sense organs, our eyes and ears. It's really about the brain's incredible power to take any data it receives from any source and build a picture of the world that makes sense.
And so that leaves us with one last kind of mind-bending thought. If our brains can literally learn to see with sound, what other incredible abilities are just waiting to be unlocked inside every one of us?